Okay, test one review. Number one, to solve by the square root property. Right there it tells you we've got a perfect square there. So when you go to take the square root of each side, I'm going to take the square root of that side. That's not so obvious. Let me use the pink. Squaring and unsquaring cancel each other out. So we've got x minus 2. You take the square root of one side, you have to take the square root of both sides. You put the radical on, so you need to consider both the plus and the minus, square root of 9. So we've got x minus 2 equals a positive 9, and x minus 2 equals a negative 9. Move the 2 over, and we get x equals 11, adding 2 to both sides. Adding 2 to both sides, we get x equals negative 7. So we have two answers. We were expecting two answers. Number 2, we're going to solve the quadratic using the quadratic formula. You need to have this memorized. If you'll write it down every time that you use it, you'll have it memorized. If you like to keep a chart there, a equals 1, b equals 3, and c equals negative 5. So we've got x equals negative, b is a 3, plus or minus b squared, minus 4 times a is a 1, and c is a negative 5. You need to look before you go down to the denominator and decide if this is going to be subtracted or added. You've got a negative times a positive times a negative. So those two negatives will cancel out, and we'll end up adding in here. All over 2 times a. Negative 3 plus or minus 9 plus 4 times 1 times 15 is 60 over 2. So x equals negative 3 plus or minus the square root of 69 over 2. Negative 5, negative 5. So 4 times 1 times positive 5, because that turned into a positive. So this is 20, so that makes 29 under there. Okay, answers are right here, and that 69 just didn't seem right, so I went and looked. Okay, number 3, solve any old way. We're going to have to FOIL this out first and then move the 6 over. That's going to be the best way to start, and then you can solve it whatever way you decide. Let's see. Okay, so I'm going to FOIL it. First gives me 10x squared. Outside is 5x. Inside is minus 8x. Last is minus 4. Let's add like terms here. And then move the 6 over. Okay, I'm looking at this. I'm not feeling like it's going to factor into 2 sets of parentheses the regular way that we factor. So I'm just going to go ahead and do quadratic formula again. I'm going to write it down, negative b plus or minus b square root of b squared minus 4ac all over 2a. If you want to keep track, we've got a is 10, b is a negative 3, and c is negative 10. So x equals, start with a negative sign, b is a negative 3. That'll change. Do it now if you feel like it. Plus or minus b squared. Be sure you put it in parentheses if you're going to put it in your calculator, so your calculator knows you want to square both the 3 and the negative sign. Minus 4 times a is 10, and c is a negative 10. And again, decide on this before you go to the denominator. A negative times a positive times a negative. That'll cancel that negative out, and we'll be adding in here all over 2a. So we've got a positive 3. The two negatives cancel. 9 plus 400 over 20. So 3 plus or minus the square root of 409 over 20. Looks good. Okay, let's look at number 4. It's one of those let mu equal problems, x to the 4th, x squared, and x to the 0. Number 5 is like that also. They're both the same kind, making the appropriate substitution to let mu equal. You'll have, we've got 2 examples on this review, but you'll have 2 examples, or you'll have 2 problems on your test, and you get to choose one. You can cross out the other. If you decide to do them both, fine, cross out one of them. The instructions will be clear. They'll be the first 2 problems on the test. It'll say pick one. If you do both, I'll grade the first one and ignore the second one. Okay, number 4. Okay, let mu equal, and then we want to grab what is behind the b, that piece right there. So we're going to let mu equal x squared. So starting back here, 0 equals, 256, plus sign, there's x squared. Let's substitute in mu. 257 minus sign, x to the 4th will always be this thing squared. Whatever sits here will always be this one squared. So we want to square that to lead the trinomial. Okay, now we can factor this. Mu and mu, signs need to be the same, and they'll need to be negative. I'm looking for 2 numbers that multiply to give me 256 and add together to give me 257. It's going to be 1 and 256. So mu equals 1 and mu equals 256. Now, this is not where you're going to quit, because the problem was in terms of x. We got to get it back into x. So let's take this and resubstitute. Everywhere we find a mu, we're going to put x squared. So x squared equals 1 and x squared equals 256. So how are we going to get x by itself? Going to have to take the square root of both sides. Whatever you do to one side, you have to do to both sides. Do that all over the place. And then you put the radical on, so you have to consider both a plus and minus 1. You put the radical on, so you have to consider both a plus and minus 1. If you're not sure what the square root of 256 is, let me show you how to do that in your calculator. Turn it on. We want the square root of 256. This is the key right in there in the gutter. So we'll do second x squared, which gives you the square root of 256, and hit enter and you get 16. So we have 4 answers. We were expecting 4 answers. Okay, let's look at number 5. Let's see, number 5 is a similar appropriate substitution problem. Okay, let mu equal whatever sits behind the b. So in this case, it'll be the square root of x. So let's go ahead and substitute it in. There's a square root of x. Let's put a mu, then 29, then a minus sign. Then there's another x. We know that that is the square of that. So let's put mu squared, and then don't forget the 6. So now we've got a normal looking factoring problem. If you would like to do this by quadratic equation, you can. You'll get the same answer. Quadratic formula, you can. You'll get the same answer. You decide. Okay, I'm seeing 6 and 5. I know to factor 6 I can get 2 mu and 3 mu, but I'm also looking at when I go multiply 6 and 5, I get darn close to 29. So if I'm going to have a middle number that big, I'm going to have 6 times 5 happening in here. So let's try 6 mu and mu. The signs need to be different because we've got a minus back here. I'm not going to worry about which one goes where right now. That's an easy solve. I want 5. 5 times 1 will go back here. I don't want to put 5 here because I want the outside to be a biggest number I can because there's a 6. If I put the 5 there, I'm going to get 30, which is darn close to 29. Put the 1 in there. Now we've got, let's check and make sure we can get negative 29 out of this. Outside is a negative 30 mu. Inside is a plus 1 mu, and that'll give us the negative 29 mu that we were looking for. So we're good. Remember, if we had messed up the signs, then we would have had a positive 29 mu. 29 mu would be good. If the sign is wrong, just change the signs. 6 mu plus 1 equals 0, and mu minus 5 equals 0. Mu equals 5, and here mu equals negative 1 over 6. Okay, this is not the answer. That's why we're using this funky little Greek letter that we don't ever use for variables, because we want to remind ourselves that that is not where we're supposed to stop. We've got to go and substitute back in because this problem is talking about x's. So everywhere I find a mu, I'm going to put square root of x. Square root of x equals negative 1/6. Square root of x equals 5. Now I've got to get this, I've got to make that look like x. So I'm going to square that, square all over the place. So the square root of x squared, squaring and unsquaring cancel each other out. A negative squared is a positive, 1 squared is 1, 6 squared is 36. Over here, 5 squared is 25. And I know we're supposed to just have one answer, but weird things happen with a radical, so we've got 2 answers. Let's look at number 6. Solve the radical equation. Okay, just like the previous when we had a radical, we squared both sides. That's what I'm going to do here. I'm going to square that side, and I'm going to square that side. So we've got and squaring both sides. Squaring and unsquaring cancel each other out. This is a FOIL problem. This is x plus 8 times x plus 8. So FOIL that out. Going to get an 8x and an 8x for the middle term. So we'll get x squared plus 16x plus 64. I see that x squared, that tells me it's going to be a trinomial, a quadratic that we're going to have to factor. It's positive right here, so these guys are going to have to come over. So minus 4x, put it in the x column, minus 44. So I've got 0 equals x squared plus 12x plus 20. That's what I'm going to have to factor here. If this bugs you, move it over to the right, no big deal. X and x, signs need to be the same and they'll need to be positive. What 2 numbers multiply to give me 20 that add together to give me 12? 2 and 10, doesn't matter where each one goes. So I've got x equals negative 2 and x equals negative 10. This is the kind of problem that has to be checked, because when you square a radical, weird things happen here. They turn positive, they don't keep their negativity. So we got to check them. Let's check negative 2. So let's check negative 2. Let's see, 4 times negative 2 plus 44 equals negative 2 plus 8. So that's negative 8 plus 44 equals 6. Square root of 36 equals 6, that works. Let's check, so this one's good. Let's check negative 10. We've got 4 times negative 10 plus 44 equals negative 10 plus 8. Right there's a problem. You can identify that because you know this radical will end up being positive, because in this country, if you don't put the radical on, and you didn't, it was first there, then we only take the principal square root, which would be a positive number, and that's not. But let's just carry it out. We've got negative 40 plus 44, so we've got square root of 4 equals negative 2, and no. So that one will not work. That's called an extraneous solution. We think it's going to work, but when we plug it in, it doesn't. Number 7, solve the equation with rational exponents. Got a rational, that's a ratio exponent, an exponent that's a ratio. Remember, this is one you can do with your calculator, but if you do it with your calculator, that's just to check. You've got to also show me that you've got this tool in your tool belt. Okay, let's look at it. And this might not even, this isn't even going to be one of those. Let's see if I've got one of those. Yeah, I do. Number 23 will be one that I was talking about. This one you won't have to do any work on, really. 3x to the 7/3 equals 15. We're trying to get the x by itself. Let's divide by 3. X to the 7/3 equals 5. And now I've got to make that be x to the first. So I'm going to raise it to its reciprocal. I'm going to raise it to the 3/7. That gives me x equals, and if I've done that to one side, I have to do it to both sides. So I end up with 5 raised to the 3/7 as an answer. You could look at this if you needed to, put 5 in there. The denominator is the index, and then we're going to raise it to that numerator power. There is no number times himself, times himself, times himself, times himself, whatever, 7 times, that will give you 5, or there is a number. It is not, though, a whole number, so we're not worrying about it. So we'll just leave it like this. If you turn it into this, I'll accept that, no problem. Okay, number 8, is this a function? Determine domain and range. Okay, let's look at domain. It's just the collection of x's. So -1, -2, 0, and 5. And then the range is the collection of y values. 6, we've already got it, we'll put it again. 0, and 5. Okay, if you write 6 twice, I don't care. I'm not sure my math lab is crazy about it, but on a test, I don't care. Okay, so that's domain and range. Is this a function? The question is, does x repeat? Let's see. -1, -2, 0, 5. I never repeated. So yes, this is a function, because as long as x does not repeat, you're good. Number 9, evaluate the function at f of x plus 2 and f of -x. This is 2 different problems. On your test, you'll only have one problem at a time. I just wanted to give you both opportunities without wasting a whole lot of paper. So we're first going to do f of x plus 2 in our function, then we're going to do f of -x in our function. So let's see, this is number 9. F of x equals 2x squared plus 8. Let's first do f of x plus 2. So everywhere I find an x over here, I'm going to put an x plus 2. Oh, there's an x. I'm going to put an x plus 2. Okay, order of operations says we have to do, please excuse my dear Aunt Sally. Parenthesis, there's parentheses, but there's nothing to do. Exponent comes next, so let's leave the 2 there, and let's FOIL this out. X plus 2 times x plus 2 will give you x squared plus 4x plus 4. Don't forget that 8. Then multiplication and division in order from left to right, so let's distribute. 2x squared plus 8x plus 8 plus this last little 8, and then finally addition and subtraction. It's 8x plus 16 is our answer for the first part of number 9. Second part asks you to take f of x, this original equation, this original function, and everywhere you find an x, instead plug in a -x. So we're going to have 2, there's an x, let's plug in a -x. And then again, order of operations says parentheses first, there's nothing to do, exponent next. So I'm going to have 2 negative x times negative x gives me x squared plus 8. So 2x squared plus 8 is what f of negative x is. Notice we put a negative x in and we got back the same old thing. So that's, if we were asked more about this, this would be an even function and it would have y-axis symmetry. Not asking that though in this problem. Number 10 says use the first graph to find the value f of 3. So this is giving you the x value. And just to remind you, if you want to pause this video, you do the work on a problem to see if you can get it right or not. I totally invite you to do that. Okay, let's see. This is the x. You're asked to come up with the y. So let's look at the function on the first graph. Let's find where x is 3. 1, 2, 3. Right there is where x is 3. Then you have to decide, you have to go find the function. We're not going to go up. The function's not up there. Let's go down. Right there is the point we're considering. They've given us the x. We give them the y. So that equals -2. Number 11, use the second graph to determine domain, range, x-intercepts, if any, y-intercept, if any, and f of 4. Okay, let's look at the domain. The domain of this guy is going to be, what does it use up on the x-axis? Well, it goes all the way to the left, so it starts using up at -infinity, goes all the way to the right, so it's using up all of the x-axis from -infinity to +infinity, all of the number line. The range, we're looking at what does it use up on the thermometer. This arrow will take us all the way down. Right here, it's not even at 0 yet. It'll get to 0, it'll get to -1, it'll keep going down and down and down. So it'll start at -infinity. How high up does it go on the thermometer on the y-axis? Right to here, there's nothing above this constant line. And that goes to about 3.5, 3 1/3 maybe. I'm just going to put a 3+. On your test, it'll be much easier to determine. No problems there. Let's see what I put over here on the answers. Number 11 to 3. Okay. It's a little bit above 3 though, isn't it? And it includes 3. It includes 3. So we're going to put a bracket. Let me make sure I did that. Yeah, I did. Good. Okay. X-intercepts. Where does this cross the x-axis? Where does our function cross the x-axis? Well, we can't see it. This is not a perfect drawing, but we can anticipate it. Maybe it's 7, maybe it's 7.5. We're just going to say 7. So the x-intercept, strictly speaking, is 7, 0. The point 7, 0. When it comes down here and hits, or 8, 0, something like that. And again, your test will be much clearer than these. So let's say 7, 0. Some of the problems you did on my math lab just asked you to identify the 7. Either way, if you want to give me the full point for the x-intercept at 7, 0 or 8, 0, wherever it is, or if you just want to name the place at the x-axis where it does get intercepted, that's fine. Same with y-intercept. This point where it crosses the y-axis looks like about 2.5. So I'm going to call it 0, 2.5, something like that, that point. On my math lab and on your test, feel free to just write 2.5 on those that accept that. And the test is fine, either of those answers. F of 4, very similar to number 10. I'm giving you the x, you give me the y. So let's go out to where the x is 4, and then let's go up to the point. We had to go up this time to find our function. And that's at about 1 1/4, 1.5, something like that. Let's call it 1.5. Number 12, the graph is in the lower right. On what intervals is it increasing? So this is a roller coaster ride. You're increasing here. You're increasing here. Where is it decreasing? It's decreasing right here. Remaining constant, nowhere is it remaining constant, so we will have none for that. Let's look at the intervals where it's increasing. Remember, we're talking about it on the x-axis. What is it doing relative to the x-axis? So this will go all the way out to -infinity. So increasing will be negative infinity to right here, and that is -1, -2, -3, -4. Remember, it's not increasing anymore once it gets to here, so we don't include -4. The other place that it is increasing begins increasing right there at 1, 2, 3, and goes on out to infinity. So also at 3 to infinity, and again, parentheses. Where is it decreasing? This part of your roller coaster ride is where it's decreasing from -4 to 3. Number 13, is this an odd function, an even function, or neither? Is it symmetric to the x-axis, the origin, or neither? Okay, let's look at number 13. Okay. The mathematical way to determine what kind of symmetry this has is to check and see what happens when you plug in a -x into this function. So let's see what happens. -x to the 4th plus 3 times -x squared plus 5. Negative raised to the 4th power, that's an even power, those will all cancel. Get x to the 4th. Negative raised to the 2nd power, those will cancel. We'll get 3x squared, and 5's not doing anything. When we plugged in a -x, we got exactly the same y. We got exactly the same thing back. -x gave us the same thing we started with. So that tells us this has even symmetry, which means it's got y-axis symmetry, just like you do. Running through your head down towards toes. And let's see, what else do they want to know? That looks like that's it. And just to remind you, if you plug in a -x and all of this had been the opposite, if we'd gotten a negative and a negative and a negative, then we'd have odd symmetry with origin. It'd be an odd function with origin symmetry. The two O's go together and these two go together. Easiest way to do this, though, is not this way. It's just to look at the exponents. That's an even number, that's an even number, and remember this is x to the 0, which is also an even number. If you've got all even exponents, you've got an even function with y-axis symmetry. Same with odd. They have to all be odd in order to have odd symmetry with origin symmetry. Number 14, I'm going to graph the piecewise function listed here. So let's look at this. We have got f of x equals x minus 3 if x is less than -2 and 2x plus 3 if x is greater than or equal to -2. Okay, first thing I'm seeing is I'm going to build a wall at -2. So there's my wall. And then I need to set up 2 t-tables. I need one for where the numbers are less than -2. -2, I'm going to leave that open. Remember, we want to see what happens right against there over here. And then -3 and -4 will be the next 2 whole numbers. Okay, this is our rule. -2 minus 3 is -5. -3 minus 3 is -6. And -4 minus 3 is -7. Let's go graph that, see what that looks like. -2, -5. 1, 2, 3, 4, 5. Right here, I'm going to leave that open. -3, -6. -4, -7, looking like that. Let's get the other one going. We need numbers that are bigger than or equal to -2. We're looking at what happens at -2, -1, and 0. Plug that into this rule. 2 times -2 is -4, plus 3 is -1. 2 times -1 is -2, plus 3 is +1, and then 0 plus 3. So we've got -2, -1, that'll be filled in there because this one's allowed to equal to -2, allowed to equal -2. -1, +1, and 0, 3, a steeper line. And that's what that's going to look like. Okay. Number 15, find the slope. Is the line rising, falling, being horizontal, or vertical? Okay, slope, we're going to subtract the y's. So it's y minus y over x minus x. So 8 and 3, I can go 8 minus 3 or 3 minus 8. I'm going to choose to go that way. So 8 minus 3 on top. On bottom, -3 minus 1. 5 over -4, and that's a good answer. 5 over -4, that's exactly the same thing as 5/4 with a negative out in front of it, or -5 over +4. As long as it's 5 over 4 with a negative in the denominator, beside the fraction, or in the numerator, those are all the same. So if it's a negative, this line would be falling from left to right. So falling there. The slope is that, and it is falling. Okay, I think that's good. Be sure you know what horizontal and vertical looks like. Okay, now we're getting into some of the pickier parts of lines here. Write the point slope form. Let me remind you, y equals mx plus b has a slope and the y-intercept. So this is called slope-intercept form, and it's kind of the holy grail. The other form, y minus y sub 1 equals slope times x minus x sub 1. That's got the slope, and it's got a point. So this is called slope-point form. Oftentimes, if you don't have all the information you need here, not oftentimes, every time, if you don't have the slope and y-intercept, you got to use this. So I call this the helper equation, slope, point. You got to have a slope and a point to use this one. To plug this one in, you got to have a slope and a y-intercept. Okay, number 16. Write the point slope form of the line. Write in slope-intercept form also. Okay, so we want both. We've got slope and we've got a point. Good, we've got enough information to use this formula. Write the point slope form of the line. Let's do that. Number 16. We've got y minus 2 equals the slope 4 times x minus -5. To remind you, the slope is 4, and they gave us the point -5, 2. So y minus 2 equals the slope times x minus -5. Let's clean this up and make this a plus. Then 2 easy steps turn it into slope-intercept form. Distribute and move the 2 over. That's it. So y minus 2 equals 4x plus 20, and then add 2 to both sides. Y equals 4x plus 22. There it is in slope, y-intercept form. This up here is point slope form because it's got the point written there and the slope. This has got the slope and the y-intercept. Number 17, give slope and y-intercept, then graph it. Okay, let's look at it. Y equals mx plus b. It's ready for us to go. You've got a slope of -3. And if you want to say -3 over 1, that's perfect because every slope has got a y movement and an x movement, up or down and then sideways. And the y-intercept is 2. If you want to call it by its full point, it's 0, 2, but you certainly don't need to do that. We don't usually do that. Okie doke, let's graph it. Graph it here. we have got slope is -3/1, rise over run. Y-intercept is 2. So let's start with the y-intercept on the y-axis, go to 2. And then from there, we're going to go down 3 and over 1. From here, down 3 and over 1. It's a -3 and a +1. Sketch that in and we're good to go. There we go. Okay, number 18 and 19 are related to each other. Write in both point-slope form and slope-intercept form, passing through -3, -4, and parallel to the line whose equation is y = -6x + 1. Okay, in order to do point-slope, we need a point. We've got a point right there. And we need slope. Oh, we don't exactly have slope, but we have enough knowledge to get it. This other line, they told us we're going to be parallel to this line. You know that parallel lines have exactly the same slope. So the slope we need, we're just going to take from there. So we're going to build a line that has that point with that slope. So the slope here is -6, and the point that we've got is -3, -4. Let's do this in point-slope form. Y minus the y-coordinate, -4, equals the slope times x minus the x-coordinate. Let's clean it up a little bit. Y plus 4 and x plus 3. So this is point-slope form right here. It's got a point, -3, -4. You have to know that they're opposites because it was formed by writing y minus and x minus, and a slope sitting right there. Now to turn it into slope-intercept, 2 steps. Distribute and move that 4 over. So y plus 4 equals -6x minus 18. And then we'll subtract 4 from both sides. Y equals -6 minus 22. And there it is in slope-intercept form. It's got the slope, it's got the y-intercept. Okay, let's do number 19. Similar problem. Write in both point-slope form and slope-intercept form, passing through 3, -4, and perpendicular to the line whose equation is given. Okay, so in order to write in point-slope, we need a point. We've got one right there. And we need a slope. They didn't give us the slope, but we can determine it because we know our line needs to be perpendicular to this one. And you know that perpendicular lines have negative reciprocal slopes. So 1/6, you got to do everything you can think of to do to it. You got to flip it, it becomes 6/1, and do the negative of it. It's positive here, so it'll be a negative for us. So the slope will be -6. So we have a point and we have a slope, and we're ready to go. So the slope here is -6. The point we need is 3, -4. We're ready for point slope. Y minus -4 equals slope, which is -6 times x minus whatever the x coordinate is. Let's clean this up a bit. Y plus 4. And now 2 steps. This is point slope right here because it's got a point, +3, -4, and it's got a slope. In order to turn it into slope-intercept, 2 quick steps. Distribute and move the 4 over. So we've got -6 plus 18. Move the 4 over. We get y equals -6 plus 14. There it is in slope y-intercept form. Slope is -6. We already knew that. And the y-intercept is 14 up on the y-axis. Number 20, write in slope-intercept form, passes through 4, 6, there's a point, and is perpendicular to the line whose equation is y equals -3. Okay, so remember that in slope-intercept form is y equals mx plus b. We need a slope. We don't have it, but we can get it. and we need a y-intercept, and we do not have that. So we're going to have to find that using the helper formula. Okay, let's see. To remind you, we are looking for a line that is perpendicular to the line whose equation is y equals -3. So a line that is equal to y equals -3, 1, 2, 3, find -3 on the y-axis right here, and then draw that in. There's the one we're trying to find perpendicular to. We know it's going to be an x equals, but we don't know exactly where. Let's see, our line, our new line, has to contain that point. So if our new line will be an x equals line, then we know it's going to have to be x equals 4. That's the only thing it can be. All of the points on the x equal line will need to be 4. So our line will be, it's going to pass through 4, 6 and will be perpendicular to this line. So 4, 6, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. There's the point 4, 6. And if we're going to be drawing in this line that is perpendicular to y equals -3 and goes through here, it's going to have to be the line x equals 4. And that's all you need to do for that. Those are really simple problems once you get the hang of the pattern. And my guess is you've got the hang of the pattern at this point. Do your homework, do the things, do the things in class, do your homework, do the review, blah, blah, blah. Okay, we've got some factoring problems here. This is the difference of two perfect squares. So I'm going to set this up. The square root of 36x squared is 6x, so I'm going to put 6x's there. The signs need to be different, and the square root of 121 is 11. Don't create an equal sign. We're done. That's it. This does not say equals 0 that we have to go further. There's the answer. And it just says factor. It doesn't say solve. Factoring this problem, this is going to be a little bit of a mess. It's going to be work because there are many ways to get 6 and there are many ways to get 15. Let's see what we can do there. 6x squared plus 19x plus 15. As you probably know by now, there are two ways to get 6. 6 times 1 or 2 times 3. I'm going to go after the way the books usually go after, which is to say the numbers that are closer to each other. So I'm going to use 2x and 3x and see if that works. Then what I'm going to do is look at the signs. I need the signs to match, and they'll need to be positive. Okay. Then 15. 15 is 1 times 15 and 3 times 5. Got a couple of choices there. I'm again going to go after the numbers that are closer together. But watch out here. Let me grab my pencil. I am not going to put the 3 right there, because that'll set up an embedded GCF. We should have taken a 3 out if this could even be true. Let's see, is there a 3 that can come out? No, 19 causes us a problem. So don't create an embedded GCF. Instead, make sure the 3 does not get there. Let's put the 3 over here and the 5 there. Now, no embedded GCF. They don't have a relative. They don't have anything that can be factored out. They don't have anything that can be factored out. Okay, let's make sure we can get 19 out of that, and then we're good. Outside here is 10x. Inside is 9x. That gives us 19x, which is what we were shooting for. So there's the answer, 2x plus 3 times 3x plus 5. Okay, number 23 has a rational exponent, and this is the one I was telling you about earlier in this review. This is the one where you can do a lot of the work in your calculator to check it, and I'll show you how, but I want to see your steps or I won't give you credit. Number 23. Okay, I'm going to have to free this guy from this set of exponent, or from this set of parentheses. I'm going to raise this entire thing to its reciprocal, to 3/4. Those will create a 1, which is what we want. So we've got x minus 5 here. And then whatever you've done to one side, you have to do to both sides. I'm going to raise 625 to the 3/4 power. This is where you can use your calculator if you would like to verify, but I'm not going to accept it if I can't see two particular steps. And I'll show you how to check it in a minute. What I want to see from you is that you turn 625, you put it under the radical, the denominator is the index, and then you set it up with the numerator. It'll be raised to that numerator. That's the first step I need to see, that you understand how to translate this into a radical. Then I want to see what you've gotten that you're going to raise to the 3rd power. This is where totally legit to use your calculator. You're looking for the 4th root of 625. So the TI calculators require that you put the index in first. So 4th root, and then let's indicate that we want that to be right there in the index. So we're going to use the key that is above the caret key. So 2nd caret. So you see the 4 is taking the place of the x, so it's the 4th root of 625, and then equals, and we get 5. That means 5 to the 4th power. 5 times 5 times 5 times 5 will give you 625. So we've got 5 there. Now I want to see x minus 5, 5 to the 3rd. A couple of ways you can do that. You can go 5 times 5 times 5 equals and get 125. You can know it. 5 times 5 times 5 is 125. Or you can do 5 raised to the 3rd power equals 125. Then you got to move 5 over, and we get x equals 130, and that's a good answer. Now the way to check way up here, 625 raised to the 3/4, 625 raised, use the caret key, raised to the, and then 3/4 is a fraction, so we're going to put it in as a fraction. 3, and then use the ABC key, ABC4 equals, and we get 125. So that would take us all the way down to there. But I still need to see, well, this isn't really a step. I need to see this, that you've converted it to a radical and that you've gotten what the 4th root of 625 is to get to 125, or you won't get credit, promise. Okay, number 24. Number 24, we've got f of x, got a trinomial there, and g of x, a binomial. We're finding g of 3, and then we're finding f of g of 3. So we'll first go after this one. That tells us grab the g equation and plug in a 3. So g of 3 equals -2 times x. Instead of an x, I'm putting in a 3. So -6 plus 8, so I'm getting 2. So that answer is 2. The second part of this problem asks you to find f of g of 3. That means go find g of 3 first, then back up and put your answer that you've gotten into the f equation. Well, we've already done this piece. This piece is 2. So we're doing f of 2. So let's go grab the f equation and plug in 2. 2 squared minus 2 minus 5. So we've got -3 there. So the second answer then is -3. The first answer is 2, and the second answer is -3. And then number 25, let's look at those two. We're looking first at x equals -3. In order to find x equals -3, go on the x-axis and find -3 on the number line. And then don't build an x line, build a y line. So there is x equals -3. Now let's go build y equals 4. Same thing except reversed a little bit. Find on the y-axis where the 4 is. Let's just thermometer, 1, 2, 3, 4. right there is y is 4, and then build this line. Let me do it in a different color. And there is y equals 4. The reason this works, for instance, on this x equals -3 line, I've shown all of the points in the world who have an x coordinate of -3. This is -3, 0. This point right here is -3, 1. This point is -3, 5. This point is -3, -3. Here, the pink line represents all of the points in the world who have a y coordinate of 4. This point right here is -3, 4. This point is 0, 4. This point is 4, 4. So all of these points along the pink line have a y coordinate of 4. Okay, we're done. Good luck on your test.